Discovery of a mini black hole may reveal secrets of giant black holes' growth. On Monday, the 10th of January 2022, at a virtual press briefing, the National Aeronautics and Space Administration shared a startling discovery that might be a possible breakthrough into the science of the growth of black holes. The Chandra program, managed by NASA's Marshall Space Flight Center, discovered a growing supermassive black hole inside a dwarf galaxy called MRK 462. Information regarding this black hole and its details were also presented at the 239th meeting of the American Astronomical Society meeting in Salt Lake City, which took place between 9th and 13th of January 2022. As surprising as it may sound for a supermassive black hole to be found inside the depths of a dwarf galaxy, it is true. Dwarf galaxies are very small, consisting of about only a few 100 million stars compared to the Milky Way's several 100 billion stars. How is it possible? We'll be discussing the science behind this in this video. But before we dive deeper into the galaxies and black holes, do hit the subscribe button on our channel and click the bell icon to be notified about more interesting videos. What is a black hole? To understand this discovery and why it is so important to do the research of space, it's first necessary to understand what exactly black holes are and how they work. Or don't, for that matter. Simply put, a black hole is a region of space-time with such a strong gravity that nothing can escape from it. If you were near a black hole, you would be sucked into it and eventually stretched and deformed into nothing. Consider it similar to a whirlpool. It sucks things inside just like a whirlpool, except the suction is probably a million times stronger. If the Earth was to enter a black hole, it would be ripped into millions of pieces due to the gravitational force inside the black hole. It's called a black hole because of its typical feature of even swallowing light into oblivion. Again, due to its gravity, at the center of the black hole is a gravitational singularity, a one-dimensional point containing great amounts of mass in a very small space. Black holes are majorly divided into 4 types. These are theoretical black holes that scientists claim formed at the beginning of the universe. Most of 1. Miniature black holes. These are already vaporized. There is no physical evidence to prove the existence of these, and scientists claim they are present. Number 2. Intermediate black holes. These two are purely theoretical. They would typically have hundreds of thousands of solar masses inside them. Some scientists think these black holes, if they exist, must have formed by the merging of miniature black holes, while others think this could be the result of the collapse of hundreds of thousands of solar masses. Number 3. Stellar black holes. Many of these black holes have been discovered, and many lie out there in the vast space waiting to be found. Stellar black holes, as their name suggests, are a result of the collapse of supernovas. If the star successively collapses into an infinitely small point, a black hole is formed. Number 4. Supermassive black holes. This is the type of black hole we are discussing now. It's millions or billions of solar masses in size. For reference, one solar mass is equal to 1.989 into 1030 kgs, or the mass of the Sun. A supermassive black hole is formed when large stars collapse on themselves, in a similar way to the formation of stellar black holes. They're supposedly formed at the same time as the galaxy they're found in, but there's a lot of confusion and conflict among the scientists regarding this. This is why the discovery of the black hole is so important. As the obvious, nobody has actually ventured into a black hole, but there are other ways to explore these deadly pits instead of committing suicide. These ways include X-rays and detailed analysis of information gathered through telescopes. How this black hole was discovered? Usually, black holes are found by observing the fast movement of stars deep within the centers of galaxies. However, dwarf galaxies, as suggested by the name, are too small for the required equipment to enter and explore these regions of space. Another way to find and confirm the presence of black holes is to get a signature of the galaxy. To do this, gas is heated up to millions of degrees before it's allowed to travel into the galaxy. As the gas moves in, glowing X-rays are used to get the signature. The researchers at NASA used the Chandra X-ray Observatory to study 8 dwarf galaxies that had shown signs of black hole activity before. Black hole activity was discovered due to the behavior of light in these regions. Activity in MRK 462 was confirmed by the X-ray signature of the galaxy. Further analysis of the signature and the fact that the large fraction of high-energy X-rays against low-energy X-rays obtained through the signature showed that this black hole was previously unidentified due to the fact that it's heavily obscured by dust and gas. This is exceptionally rare. However, this discovery also gives a heads up to the existence of much more cloaked black holes. In fact, Ryan Hickox, who is an observational astrophysicist, says because buried black holes are even harder to detect than exposed ones, finding this example might mean there's a lot more dwarf galaxies out there with similar black holes. He further added, this is important because it could help address a major question in astrophysics. How did black holes get so big so early in the universe? But before we move on to what exactly this discovery means, we shall quickly gloss over the specific features of this supermassive black hole hidden inside the MRK 462 dwarf galaxy. Features of this black hole. This supermassive black hole is comparatively smaller than other supermassive black holes, compassing only 200,000 solar masses. We know that supermassive holes can have several 100,000 solar masses inside them. Like most supermassive black holes, the growth of this black hole is also exponential when compared to the age of the universe. This leads us to the final question: why is this discovery so important? What this discovery means? The phenomenon we just discussed, that black holes are far greater in size than the age of the universe, has perplexed scientists and astronomers for a long time. Due to this phenomenon, there is a great disagreement between scientists, researchers, and astronomers. According to one group, a possibility is that these black holes were formed when massive stars collapsed to form black holes that weighed only about 100 times the mass of the Sun. However, theoretically, it seems impossible that black holes were born this way. It's extremely puzzling how black holes could so quickly encompass the large masses most were proven to have in the early universe. The only other theory scientists have been able to present regarding this is that when the universe was born, small black holes compassing a good amount of solar masses were already present. Or as NASA's official website stated, an alternative explanation is that the early universe was seeded with black holes containing tens of thousands of solar masses when they were created, perhaps from the collapse of gigantic clouds of gas and dust. The discovery of this black hole favors the second of these views. This view was believed by just a few scientists. However, this black hole has given scientists and astronomers a great leap into the science of black holes. Most astronomers at NASA have taken up research of the black hole phenomenon with renewed zeal. This is because black holes aren't just shrouded in gas and dust, but also in tons and tons of mystery. The first ever black hole being discovered in 1971 makes black holes a considerably recent discovery. Combining this with their supernatural physics, black holes are ever confusing and perplexed, not just for the public but also for the greatest scientists, researchers, and astronomers. While scientists have given many different views regarding this discovery, one thing is for certain. This discovery gives us the incredible chance to understand our cosmos in a more in-depth manner, thereby marking the start of something wonderful. All in all, the summary of this entire video can be concluded in one statement given by Jack Parker, who's a colleague of Ryan Hickox. We can't make strong conclusions from one example, but this result should encourage much more extensive searches for buried black holes in dwarf galaxies. He also added, "We are excited about what we might learn. Not gonna lie, we are also excited to see what the future holds for us after this fantastic and fascinating discovery."